Hey everyone, welcome to the 12th episode of the Wio Terminal Classroom. So in this episode, I will teach you how to use a soil moisture sensor, a temperature and humidity sensor, the built-in buzzer and the light sensor on the Wio Terminal, and build a simple smart garden project. So now, without further ado, let's jump straight into the video. So now let's look at what we are going to build in this video. So we will be building this simple user interface on the Wio Terminal LCD screen, and we will connect the temperature and humidity sensor, the soil moisture sensor into the Wio Terminal and obtain the data and display on the LCD screen. Also we will use the inbuilt light sensor to display the light sensor information. So what kind of hardware and sensors are we going to use in this project? So we will be using the Grove temperature and humidity sensor, which is based on the DHT11 sensor, and it will be very easy to connect this to the Wio Terminal using the 4-pin Grove cable. So you can go to our Grove homepage and learn more about different Grove modules in the Grove family. Also we will be using a soil moisture sensor, and in this video I will use a general soil moisture sensor like this, but you can also use the Grove soil moisture sensor to connect to the Wio Terminal. So I will explain you how to use both the sensors with the Wio Terminal. And next I will be using the built-in light sensor and the built-in buzzer on the Wio Terminal. So this is the light sensor which is on the Wio Terminal. So if you look at the back of the Wio Terminal, to the top left side of the microSD card slot you can find the light sensor. And the buzzer can be found at the front of the Wio Terminal. In this project, when the soil moisture level is low, the LCD will give a warning with a buzzing sound to remind the user to water the plants. Now let's go ahead and start testing the sensors and hardware that we are going to use in this project. So first we will be using the Grove temperature and humidity sensor. So start by connecting the Grove temperature and humidity sensor to the Grove digital port on the Wio Terminal. So this is the Grove digital port on the Wio Terminal, and now let's connect it to this port. So now let's configure the necessary software to use the Grove temperature and humidity sensor. So first let's download and install the DHT library. So go to this link. I will give a link to this URL in the video description. So download it as a zip file. After that, open Arduino and go to Sketch, include library and add .zip library, and point to the location where we just downloaded the library. So this one, open it, and you have successfully installed this library. So now let's start writing our codes. So first let's include the DHT library. So dht.h. So I will comment it here, DHT library. So after that let's define the DHT pin. So hashtag define DHT pin and define it as 0, because here we have connected the sensor to this pin, the D0 pin. So we need to define it as 0. After that we need to define the DHT type. So hashtag define DHT type, and here we use DHT11. So if you use DHT22 sensor, you need to define this as DHT22. So define DHT sensor type. Then we need to initialize this DHT sensor. So DHT pin and DHT type. So initializing DHT sensor. So now let's move on to the setup. So inside the setup, let's start serial communication. So serial.begin and set the baud rate to 9600. So start serial communication, and then start the sensor. So dht.begin start DHT sensor. So now let's move on to the loop. So inside the loop, let's define variables. So let's define this t as an integer and assign it to dht.read temperature So this is to obtain the temperature information from the DHT11 sensor. So this T will store all the temperature information. So for humidity information, let's assign a variable as H and write DHT dot read humidity. So that will save the humidity information on H. So this is assign variable to store temperature, and this is assign variable to store humidity. After that, let's print out this information. So serial.print and temperature and serial.print ln. So this will create a new line, and T, so that is print temperature values, and then serial.print humidity, serial.print ln and H. So this will print humidity values. So now let's upload this code to the board. Now let's move on to testing the soil moisture sensor. So I told you before that I'm going to use a general soil moisture sensor in this video. So you can follow this diagram to connect a soil moisture sensor to the 40-pin GPIO header of the Wio terminal. However, if you are going to use a Grove soil moisture sensor, you can connect it to the Grove analog port on the Wio terminal. So in both the methods, I have connected the moisture sensor to the A0 port. So here you can see pin 13 is A0, and here this analog pin is also A0. So this is because this pin and this pin are both connected internally with each other. So now let's move on to writing our codes. So first, let's define some variables. So int sensor pin. So this is to define the sensor pin. We'll define it as A0 because we have connected to A0 pin. So define variable to store sensor pin. After that, we will define another variable to store the sensor value, set it to 0. So define variable to store sensor value. Then inside the setup, let's start serial communication. So serial.begin and set it to 9600 baud. Start serial communication. After that, let's move on to the loop. So inside the loop, let's type sensor value. So this is the variable that we defined before, and equal to analog read sensor pin. So this will store sensor values into sensor value variable. After that, let's serial.print soil moisture So this will print soil moisture on serial monitor, and type serial.print ln, so new line, and sensor value. So print sensor values. After that, let's add a delay of 1 second, which is 1000 milliseconds. Now let's upload this code to the board. So before using the soil moisture sensor, we need to calibrate it. So the soil moisture sensor sends out analog signals to the Wio terminal when it is connected. So these analog signals are converted to digital signals by the 10-bit ADC, which is an analog to digital converter inside the Wio terminal. So through this ADC, it will output 1024 values. So the ADC value range will be between 0 and 1023. So the highest sensor reading will be 1023 and the lowest sensor reading will be 0. So first you need to dip this in dry soil and check the sensor value. So I have tested and got 1023 as the value in dry soil, and then add water to that soil and make it wet, and then dip the sensor into this soil and check the readings, and I have got 400 as the reading in wet soil. So for now we will keep the values as this, and we are going to use these values later in our final code. So now let's test the light sensor on the Wio terminal. So in my previous videos I have explained you how to use the light sensor on the Wio terminal. So if you go to the Wio Terminal Classroom playlist, you can find the classroom number 10 video explains about how to use the light sensor on the Wio terminal. So in this video I have explained you some simple demos of using the light sensor as well. So I will give a link to this URL in the video description so that you can also check this video. So the light sensor pin definitions are defined at variant.h file. So if you go to this location, you can find the variant.h file, or else you can search here in the search bar and then open it. After that, type light sensor and you can find the light sensor pin is defined as Wio light. So let's open Arduino. So now let's start writing our codes. So inside the setup, let's define the light sensor pin. So pin mode Wio light and set it as an input. After that, let's start serial communication. So serial.begin and 9600 baud. Then inside the loop, let's create a variable called light equal to analog read Wio light. So that's the light sensor pin. After that, let's serial dot print and type light value. So this will print on the serial monitor. Then serial dot print ln new line light. So this will print light sensor values. After that, at the delay of 200 milliseconds. Now let's upload this code to the board. Now let's move on to talking about the buzzer on the Wio terminal. So if you want to learn more about using the buzzer, I have made a video before in the Wio Terminal Classroom 9 video. So you can check this video and learn how to use the buzzer. So I will give a link to this URL in the video description down below. So before using the buzzer, you need to know the pin definitions of the buzzer pin. So you can visit the variant.h file and search for buzzer, and then you will see that the buzzer pin is defined as Wio buzzer. So now let's open Arduino. and let's start writing our codes. So inside the setup, let's set the buzzer pin. So pin mode Wio buzzer and set it as an output. So setting buzzer pin as output. After that, inside the loop, let's beep the buzzer for 1 second. So to beep it, analog write Wio buzzer, set it to 150 analog value and delay of 1000 milliseconds, which is 1 second. After that, let's silence the buzzer for 1 second, analog write Wio buzzer, set it to 0 and then add a delay of 1 second. Now let's upload this code to the board. So now it's time to combine the sensors that we have tested before and build this simple smart garden project. So let's move on to the hardware overview. So first you need to connect the temperature and humidity sensor to the Grove digital port on the Wio terminal, and you need to connect the soil moisture sensor to the 40-pin GPIO header by following this diagram. So now we have opened Arduino and we will start writing our codes. So first let's add the libraries that we need. So first let's include the TFT library. So TFT espi.h TFT. Then let's include the DHT library. So dht.h. After that, let's type the definitions. So hashtag define DHT pin and set it to 0. So that's define pin of DHT sensor. Next, define the DHT type. So hashtag define DHT type. Define it as DHT11. So define DHT sensor type. After that, let's do the initialization. So initializations. So DHT pin, DHT type. So that's initializing DHT sensor. Then let's initialize the LCD screen. So ESPI TFT. After that, let's initialize the buffer. After that, let's do the soil moisture definitions. So soil moisture sensor definitions. So let's add a variable. So sensor pin, and let's set it to A1 because we have connected the soil moisture sensor to A1 pin. So define variable store soil pin, and then let's set another variable, sensor value, set it to 0. So define variable to store soil moisture sensor value. After that, let's move on to the setup. So inside the setup, define the pin. So pin mode Wio light. So this is the light sensor, and define it as an input. After that, set the buzzer as an output. Now let's start the DHT sensor. So After that, let's begin the LCD screen. Then let's set the rotation of the screen. Set it to 3. Finally, let's create the buffer. Height, TFT, width. So now let's write our codes inside the loop. So let's assign this variable T to DHT read temperature. Variable to store temperature, and then assign another variable H to store humidity. So DHT dot read humidity. Then let's assign a variable to store light sensor data. So Wio light After that, let's start drawing this user interface on the Wio Terminal LCD screen. So first, setting the title header. So that is this header. So spr.fill sprite. So that is to fill the screen in white color. Next, let's draw this rectangle. So fill rect, start at 0x location, 0y location, and the length will be 320 pixels, height will be 50 pixels, and the color will be dark green. After that, let's set the text color, set text color to white. Then set the text size to 3. Finally, draw the string. So SPR draw string, write as smart garden at 50x and 15y location. After that, let's draw this vertical line and this horizontal line. So SPR dot draw first. So 150x, y 50, and the length will be 190. Color will be dark green. After that, for the horizontal line, 140y, 320 is the length, and the color will be dark green. Then let's draw for this the temperature. So setting temperature, set the text color to black, and text size to 2, and draw string as temperature at 1065. Then let's set another text size, set it to 3. So that is for this one, and then SPR dot draw number, and we'll pass the t value. So this t is the variable that we assign to store the temperature values. So t 50x and 95y. Finally, let's draw a string as C, that is Celsius, 90 and 95. Now let's set for the humidity here. So setting humidity, SPR dot set text size, set it to 2. Then let's draw the string as humidity, location 25, 160. Set the text size, change it to 3, and SPR.draw number. So let's print out the humidity value. So H, this value that we defined before, the variable that we defined before. So H 30, 190. Finally, SPR.draw string percentage RH, because this is the relative humidity percentage, 70, 190. So now let's set for the soil moisture. So setting soil moisture. So let's add a variable sensor value, analog read sensor pin. So this will store sensor values in sensor value variable. So we have defined the sensor value variable here as an integer. Then let's type sensor value equals. Now we will use this map function to map the sensor value as a percentage. So we are going to display sensor value as a percentage. So I have shown you before that when we calibrated the soil moisture sensor, the value in dry soil was 1023 and the value in wet soil was 400. So what we will do here is we will map sensor value. So this value, we will map the values 1023 to 400. So that's the range. We will map it to 0 to 100. So this 1023 will map to 0, 400 will be mapped to 100. And this 1023 to 400 range will be mapped to 0 to 100 range, because we will be displaying as a percentage. After that, let's set the text size. So SPR dot set text size, set it to 2, and draw a string as soil moisture. The location will be 160, 65. Then set the text size again to 3. That's for this one, the value. So SPR dot draw number, type sensor value. So that is this variable that will give out a value between 0 and 100. The location will be 295. Display sensor value as percentage. Finally, draw the string SPR.draw string percentage, location 240, 95. Now let's move on to setting for the light sensor. So setting light. So let's SPR.set text size, set it to 2. Let's draw a string. The string will be light. Location will be 200, 160. And let's change the text size to 3. So that's for this. And let's type light. So we have defined this variable light here. We have defined it as an integer. So let's map. So we have used map before for the soil moisture sensor value. Now we will map the light sensor values. So light, so 0 to 1023, so that's the ADC value range, map to 0 to 100. After that, FPR dot draw number, type light, so that will display the light sensor values as a percentage. So it will display a value between 0 and 100. Location will be 205, 190. Finally, SPR.draw string, draw the percentage. Location will be 245, 190. So now let's set a condition to change the display and beep the buzzer when the soil moisture level is low. So let's go ahead and set that condition. So condition for low soil moisture. So if sensor value that we have defined before, this sensor value, if it's less than 50, SPR dot fill sprite TFT red. So the display will turn red and it will display text as time to water. The location will be 35, 100. After that, let's beep the buzzer. So analog write, Wio buzzer 150. So beep the buzzer. So at a delay of 1 second, and then analog write, Wio buzzer 0. So that's to silence the buzzer, silence it for 1 second, which is 1000 milliseconds. Finally, let's push this code to the LCD. So 0, 0, push to LCD with a delay of 50 milliseconds. Now let's upload this code to the board. So one thing I want to mention, and that is when you use the Grove soil moisture sensor instead of the sensor I used in this video, you can connect that sensor to the analog port of the Wio terminal, and the temperature sensor can be connected to the I2C port of the Wio terminal. However, when you define these pins inside the Arduino code, you need to make sure to change this soil moisture sensor to A0, because here we have connected the soil moisture sensor to the A0 pin. And here the I2C port can be used as a digital port. So to use the I2C port as a digital port, you can define it as pin via SCL. So here you can change this, I'll comment it. So you can define it as DHT pin via SCL. So when you do this, it will use the SCL pin of the I2C port. So that's it for this video. If you guys like this video, please give a thumbs up and subscribe to our YouTube channel to stay updated with us. So see you guys in the next video.